Nolan, thanks for having me. And welcome everybody. Thanks for taking some time out of your day to learn a little bit more about Windows Server 2016. And in this particular session, we're going to be focusing on all the enhancements around virtualization and looking at how we're not just virtualizing the compute layer anymore, but also the storage and the networking. And then a lot of the different clustering features that are part of that to help provide high availability for your virtualized environment. As Noel said, I spent some time with Microsoft. I spent about 8 years over there, splitting my time up between the engineering team, where I worked for clustering, building some of these virtualization high availability features, and then as a technical evangelist. And about a year ago, I left Microsoft to join one of Microsoft's software partners, Five9, and we built security and management solutions for Hyper-V as well. So I'm still fairly active in the community and was recently awarded the Hyper-V MVP award. So let's go ahead and get started, and we'll show you what we're going to be covering today. So first thing we're going to talk about are the new enhancements around upgrades. Again, we're going to then go through the different layers of compute, network, and storage, and then look at some other enhancements in the platform, which are primarily around security and hybrid cloud. So first thing is, how are we going to go ahead and upgrade to Windows Server 2016? Hey, Noel, I just noticed that the recording stopped. I'm not sure if that was planned or not.
No, Simon, it was unfortunately my link crashed. Oh, my Skype crashed.
No worries. It looks like we're back. All right. So first enhancement here is talking about upgrading to Windows Server 2016. This is going to be one of the biggest investments that the cluster team did, giving you the ability to
Simon, can you hear me? Simon?
Yes, I can. It looks like I was muted as part of that. I apologize, guys.
Sorry, Simon. Do you think you can rewind a few slides?
Let's do it again.
Yeah. Thank you.
Apologies, folks. We'll try to get this going a little smoother here. So what we're trying to do here with the rolling cluster upgrades is have do an easier way to go and move from the old version to the new version with no downtime for the virtual machines. Now, in the past, when you wanted to move from a 2012 to 2012 R2 cluster, you'd actually have to set up a second cluster and copy the different VMs from the first over to the second. And this worked fine because you could still do a live migration. However, you had to actually deploy a second cluster, which meant that the cluster itself had a new name. So you would often have to reconfigure any applications that were interacting and using that cluster. What we can now do with the newest version is just go through the exact same cluster and upgrade all of these nodes one node at a time. Now, the first thing behind the scenes which allows us to do this is a new property known as the cluster functional level. And you can kind of think of this similar to the Active Directory functional levels for the different forests, where today everything is going to be working on 2012 R2, and then as you gradually upgrade the nodes one at a time, once everything's upgraded to 2016, then you can run this commandlet. It upgrades the entire cluster to 2016, and you can start taking advantage of the newest nodes in the cluster and all of the latest features. So as we take a look at this in a little more detail, let's say that I have a 5-node failover cluster, and they're all running the old version, Windows Server 2012 R2. And you can see that the cluster functional level is also at this version. So what we're going to do here is pause one of the nodes on the cluster, and pausing a node basically puts it into maintenance. So it's going to live migrate everything off of that node and not allow anything to move back on. It's kind of like it's draining the node. Now once that node is drained, we're going to go and kick it out of the cluster. We're going to go and upgrade it to Windows Server 2016. And then we're going to go and add it back into the cluster. And again, this was the big change from last time. In the older version, you couldn't go and add this mixed mode back into a cluster. All of the nodes had to be the same. Now we still have a single cluster, yet one of the nodes is 2016. We're then going to go repeat this process for the other nodes in the cluster, where we will pause them, put them into maintenance, and upgrade them one at a time. Now once we're on our final node in the cluster, as we've live migrated all of those VMs and upgraded it, we now have all of the nodes in the cluster running at the Windows Server 2016 level. However, our functional level is still the old version. And what this allows us to do is we can do testing to make sure that our applications are still performing well on the 2016 platform before we go and make the full commitment to 2016. So if during this test period certain applications aren't working well, there's performance issues, it's relatively easy to roll back during this process. Once we're comfortable that everything's on the next version, we'll go and run the commandlet to upgrade the functional level to 2016, and then all of the nodes will have access to the latest features. Now, if you're just deploying an enterprise architecture with Hyper-V, you don't just have the physical servers that run the virtual machines. There's actually a whole nother set of servers that are used to provide high availability using scale-out file server. And what the scale-out file server does is it essentially provides access to the virtual machines and keeps that access path highly available. So Hyper-V has a feature known as Hyper-V over SMB. And what that basically means is you can run your virtual machines from a Windows file share. So the disk path for my virtual machine might be mydisk.vhdx. Now to keep that file path highly available on the file server, there's this technology you can use, scale-out file servers. It maintains high availability for the access to the virtual machines, and this itself can also go through this rolling upgrade process. So the whole idea here is to make this rolling upgrade process easy, clean, and available for all 2012 R2 Hyper-V clusters. So let's take a look at some of the enhancements around compute first. Now, scalability has always been a big one with Microsoft. Microsoft's generally been ahead of VMware when it comes to producing the largest scale numbers. So Microsoft had the largest scale numbers in the industry until recently when VMware actually released version 6.1. And in 6.1, they leaked a couple of the different Microsoft features. But rest assured, Microsoft is going to be updating all of their scale numbers as soon as launch comes out to make sure that they continue to lead with the most number of VMs in a cluster, most VMs per host, largest amount of memory, all of those different components. And I often get asked, why isn't Microsoft doing this ahead of time? Why did they wait so long before they released this number, since VMware's already announced their numbers? Well, speaking from what happens on the engineering side, keep in mind that the Windows Server 2016 product, it's still actively being built. So even though the core features are in place, a lot of the engineering time spent now during the release candidate phase is all around performance, optimization, reliability, trying to make things work as efficiently as possible on the new platform. So Microsoft waits until the very, very end before they start doing their scale testing so that they truly believe that they have the fastest, most performant code before they actually do the testing against it. So stay tuned on this one. Right when Windows Server 2016 is going to be launched, which is going to be in probably about 4 to 6 months. They haven't announced an official date yet, but about 6 months from now, you'll see larger scale numbers as well. Another competitive advantage Microsoft continues to really be proud of is how the Microsoft applications work better on Hyper-V. And the big strength around this is that the engineering teams really do collaborate together. If there's some unusual type of performance issue on SQL Server, the SQL lead, the Hyper-V team, they could come together and they can mutually resolve it to really try to optimize every single Microsoft workload running on the platform. You're going to continue to see a lot of enhancements around using the latest type of live migration technologies, making them move faster, taking advantage of hardware-assisted live migration, using what's known as remote direct memory access, and a lot more flexibility around being able to dynamically scale up, scale down every piece of the virtual machine without having to take it offline. So you can now add disks, you can add memory, you can add network adapters, no downtime to the virtual machines themselves. Now, we also tried to address some specific features which were recurring problems around Hyper-V. And one of the most common problems with failover clustering was when you had a bad node and how that was disruptive to the environment. So what Microsoft found from a lot of real-world testing was that if a customer's node kept crashing or crashed once, there was an extremely high probability that it was going to crash multiple times. It might have a bad firmware, it might have some other issue, but it would continue to crash. Now, the problem with this scenario is anytime a node crashes and then recovers, it rejoins the cluster. And this means that virtual machines move back to it to help balance the load. But if that node crashes again, those virtual machines are going to crash again. They'll move somewhere else, the node comes back online, they move back. So this is actually a relatively disruptive action because it's actually causing VMs to crash. So what happens now with a cluster is if we see that a node crashes more than 3 times within an hour, we're going to go and put it in a quarantine state, which basically says there's a problem here, the administrator needs to look at it, but we're not going to go and move anything to this node in the cluster. Now these settings are configurable, the number of crashes, the duration, so you do have some flexibility here, but this is really going to help administrators be able to isolate a faulty host and stop bringing virtual machines to it. Now, there's also been a lot of enhancements around cluster diagnostics. There's a couple of additional tests with the validation tool that are going to make sure that it's even more compatible with Active Directory and that you can deploy cluster nodes in entirely isolated environments with no Active Directory dependence at all. The time for the validation test has also been enhanced. And one of the most common complaints troubleshooting customers had with clustering was the fact that the cluster log wrapped and wasn't synchronized well. And so what I mean by that is, in many cases, you might have a cluster that's stretched across multiple time zones. You know, you could have one cluster node or one data center maybe in Perth, another one in Kuala Lumpur, and they actually have different local times. Well, anytime you actually had to go and troubleshoot the cluster, you would have to go and aggregate the data from the first cluster node and the second cluster node, and it would get merged together into a log. But because they were in different time zones, that log would actually become a little odd. It wouldn't be consistent, and things would be out of place. So they've addressed this issue by localizing the time when cluster logs are collected. And the second major issue that's been fixed here is if the cluster log contained too much data, it would actually wrap on itself. So let's say, for example, you specify that the cluster log could be 16 megabytes. Well, if you had a problem that was only happening, let's say, once every week over on the weekends, by the time that problem happened and you came back to work on the Monday to try to go and view it, there might have been so much data that was written to it that you've actually lost the error. So rather than having the cluster logs wrapped, they're now extensible and gives a little more control over how you manage each of them individually to have better troubleshooting. Now, the next big area of investment has been around Linux integration. And a lot of people have been surprised about Microsoft's effort to contribute to the Linux community, because anytime you deploy a Linux virtual machine, that's a Windows license that is not being sold by Microsoft. So about 2 years ago, Satya Nadella, Microsoft's new CEO, he wrote a very interesting blog post entitled Microsoft Loves Linux, and talked about all the different ways we were improving interoperability. And probably the biggest is that we actually have Linux engineers now, people from the open source community working at Microsoft, and they're actually directly checking code into the different Linux distributions. Now what this means is this code that gets checked into all these Linux distributions tells that Linux operating system how to work with Hyper-V. So if it's running inside a Hyper-V virtual machine, we have the ability to start it, stop it, do dynamic memory, and do a lot of other controls like checkpoints. And previously this was unavailable. And so now, as soon as a new Linux virtual machine gets deployed, it's immediately enlightened. It knows that it's running inside a Hyper-V virtual machine, and it can be controlled by that Hyper-V host. And you may see Microsoft continuing to talk about these investments. For example, just last week, Microsoft announced that they're now going to support SQL running on Linux. So you can have a Linux operating system and run SQL Server directly in it. So certainly if you're a Linux shop here or looking at ways to save some money on licensing, this is a great option for you as well. Now some of the other smaller enhancements that have been made around Hyper-V with this release is giving you the ability to add static memory with no downtime to the virtual machine. Previously, if you needed to be able to adjust how memory is being used, to grow it up or down, you had to turn this feature on known as dynamic memory. And that would basically have the system control how it gets scaled up or scaled down. But in many cases, especially for hosters or service providers, they needed to assign a fixed amount of memory for each virtual machine because they don't want any type of memory attack where one virtual machine is using up too much resources and starves the memory for those other VMs on that same host. So now you have the ability to assign a fixed amount of memory but still adjust that as needed without any downtime to that virtual machine. We've also added the ability to add and remove network adapters with no downtime to the VM as well. So this is great for dev, testing, and being able to quickly try different access points to virtual machines without having to bring them offline. One of the biggest enhancements as well is a new technology known as production level checkpoints. And you can see this in the screenshot over on the right. So first of all, what exactly is a checkpoint and how is production different? So a checkpoint in Hyper-V is when you essentially select a virtual machine and you tell it to save all of the running virtual memory to a disk. And what it's going to do is basically take that 1 gigabyte or 4 gigabytes or whatever that virtual machine is using and go and save what's active there onto a disk. And a lot of people do use this in production, but the reason why it's not supported technically in production is because you don't guarantee the integrity of any data. So if you're doing this checkpoint, let's say for example on a domain controller, or you're doing it on a SQL database, and there's transactions that are on the fly, you might actually lose this information. So this has been the reason why Microsoft has never said use this in production, just use it for dev and test. So what's been different now is they've now added what are known as production checkpoints. And nowadays, when you go and actually take a checkpoint, you actually call in the built-in backup writer component, which is known as VSS. So basically, when you say, I want to go and create a checkpoint now, what it is going to do is flush out all of the different buffers. It's going to make sure that the file system buffer, the network buffer, database, all of these different components are now clean. There's nothing that's active in them, nothing that's on the fly. So this way you're guaranteed to get a complete snapshot and not have any data loss. Now for me, this seems like a no-brainer, right? Everybody wants to use this, why wouldn't you? One limitation that I personally found that I don't like is if you do a production level checkpoint, when you actually restore it, it restores from a cold boot. So what I mean by that is when you're taking this production level checkpoint, it's actually going to close down all the consoles for you, and it's basically almost going to shut down that VM. It doesn't allow you to keep things active, keep things open. So that when I do a recovery and I restore from this production checkpoint, if I had, let's say, a System Center running, it wouldn't be running. I'd have to then go ahead and launch it. So it's kind of a trade-off here. It shuts down applications that are active, but it guarantees the data integrity across it. Some other improvements have been around Hyper-V Manager. You can now connect using different types of credentials. You have better down-level management to older versions. And you can provide alternative credentials to connect to a virtual machine too. Another big enhancement that's going to probably throw off a lot of people is that the VM's configuration file is now encrypted. So what is the configuration file? So the configuration file for a virtual machine basically tells you the different settings. What's the name of the VM, the amount of memory, storage, network connections, things like that. Now, in the past, this was saved as plain text in an XML file. And so what that meant you could do is you could open up the XML file, edit some of the different settings, and that would change the VM. Well, there were kind of two problems with this. First was around security, because there were malicious scripts that would run in the data center, find these files, and go and steal information about the settings of the virtual machines. They might change them even, being able to write to those plain text files. So first, there was that security issue. The second challenge with using the plain text files is administrators are not supposed to edit them directly. Because if you edit that file directly, and then that virtual machine moves to a different node, let's say due to a failover or something like that, the other nodes don't know that changes were applied, and so those changes do not get copied over to the second node. Now, if you go ahead and you edit the information through the GUI, which then edits the file behind the scenes, Hyper-V Manager knows that a change has been made. So when that VM moves to a different node, it's also going to go move that configuration information. So for these two reasons, that there were these security vulnerabilities and that administrators were making changes that were not being applied, the Hyper-V team decided to encrypt the file format entirely. So there's no manual editing possible. If you open it up, it just looks like a lot of unusual characters or binary, things like that. This is going to help provide some stability and avoid one of the big security gaps with Hyper-V. And finally, Hyper-V teams also implemented their own change block tracking driver. And what this basically means is that third parties such as my company, Five9, we can now plug into a local driver that figures out which pieces of a virtual machine have changed, such as the memory disk network. So this gives us a little more control over being able to do more efficient disk scans, things like that. Now, as I go along, please, of course, feel free to type any questions in the chat. I'm going to be showing this slide, and then we're going to be switching over very briefly to Noel, and he's actually going to show you a demo of this slide here. So we're going to be taking a look at nested virtualization. So first of all, what is nested virtualization? Well, it gives you the ability to run VMs within VMs within VMs, down to as many levels as you have enough capacity or memory for. Now, VMware's actually been doing this for a while, and it's been one of the competitive differences they like to boast about. Now, the challenge, though, is, for several years, Microsoft has said, is it worth us doing nested virtualization? What are the real scenarios people use this for? Nested virtualization is great for labs because if you only have one server, it's really tough to go and simulate how a cluster is going to work. But now using nested virtualization, I can have my one physical host. I can run multiple VMs within that and run VMs within VMs within VMs. So I could basically build any type of test environment without limits. But anytime that you go through this layer of VMs within VMs within VMs, you actually add an overhead. There's something like a 10 to 15% performance overhead. And this will vary once launch happens, but there is a performance head having to do VMs within VMs within VMs. And so in production, there hasn't really been many good use cases. Because in production environments, you need more than one physical server, or you have a single point of failure. Now, that's been kind of the core reason why Microsoft hasn't released this before. And I mean, I've been personally involved in the conversation for a couple of years. As somebody that did a lot of demos and lots of labs, nested virtualization would have been extremely beneficial to me. But now they finally released it, and the big feature that this is being done for is a new technology known as containers. And we'll talk about what containers are in a moment, but first I'm going to turn it over to Noel, and he can actually walk you through a demo of nested virtualization.
Thank you, Simon. Sorry, I'm a bit croaky this morning after a couple of days in Bangkok, doing almost non-stop sessions. So what I'm going to do is I'm going to take over the screen.
I'll let you know once that comes through.
Thank you. Can you see my screen now?
It is loading. You should be good to go in a moment. I think you'll probably appear for the others a little. Yep, you are good to go. Let's do it.
Okay. So just to give you a bit of background, right? So this particular machine that you're looking at is my host, if you want. Okay, so now how do you tell it's the host, right? So when you talk about VMs, within VMs and so forth, there's multiple layers. So in this case, I think one of the best ways to show you that this is actually the host is probably the system information or the device manager. All right, so let's have a look at the device manager. So if I go into the properties of my PC and go into device manager, one of the things, oh, hold on, this is not my physical box. As you probably can see that a lot of the drivers are all showing up as my Hyper-V virtual machine drivers. Just hold on for a sec. Let me just close this down. Let me just see where is my Hyper-V host. I think I've got this on too many screens. Hold on. Pin? I don't want it pinned. Okay. There you go. So this is my physical host, if you want. All right, so sorry about that. Can all of you still see the screen? Simon?
Yes.
Simon? Yeah? Okay, very good. Thank you.
Yes, good to go.
Okay, cool. All right, so this is my actual Windows 10 screen, actually. All right, just to give you an idea, the properties of my PC. Right. Sorry, I was already in full screen just now, so as you can see, I have a lot more devices than what the virtual system showed up with earlier. All right, so from the video adapters to my network ports and my storage controllers and so on. As you can see, I have things like my Gigabit, my Centrino and so forth. So this is my host, right? And dropping back to my actual virtual machine earlier, you would have seen that the settings were a little bit different. So this is my virtual machine that is running on top of this particular host. And just to give you some confirmation in addition to that, let's have a look at my virtual switch manager. My virtual switch manager will immediately take you to see that I'm actually got my virtual switches connected to things like my Gigabit LAN or even my Wi-Fi if I connect it to the external Wi-Fi, like say my Centrino adapter. Right, so from here you can see that this is my host with my virtual switches connected to physical adapters. But when I switch you back to my virtual machine, you realize that I see my network virtual adapters that are all running in virtual, like this, for example, the Hyper-V network adapter, as well as the Hyper-V virtual Ethernet adapter. Okay, so within that, because of nested Hyper-V or VMs within VMs, I can actually show you that I have Hyper-V enabled. So the process of turning that on essentially is just going through the motion of adding a role. And in this case, like a cooking show, I've done it ahead of time for you so that this doesn't require the couple of reboots that is normally needed. As you can see, Hyper-V is already installed in this particular virtual machine. And what that allows me to do is to bring up another instance of Hyper-V Manager. Right, so let's go into full screen so at least it's probably a bit easier to see. So in this particular Hyper-V, you notice that I have my virtual switch manager, but in this case, when you look at my external virtual switch, which is pointing to my adapters, it shows up as the Hyper-V network adapter. I don't see those physical adapters anymore, like the physical Gigabit or the wireless adapter. And if I try to start up this, which is a brand new virtual machine that I created, just want to quickly show you the settings of my virtual machine. All right, so I have a virtual disk connected to it. I have a single virtual processor. I have 1 gig of memory. and so on. All right, I can even tell it to boot from DVD, the hard drive, and so on. So what I'm going to do now is I'm going to attach an ISO file into this virtual machine and boot up that ISO file and install an OS within this nested virtual machine if you want. So feel free to type questions into the chat column so that, oops, hold on. Let me try this again. Because I noticed there seems to be a little bit of a bug when you try to do this too many times. And I'm sure the product team will fix it by the time they release it. Interesting. This is definitely a day not for good demos. Okay, no worries. I'm just going to shut this down first. I'm just going to go through and create a new one. That's it. And I'm going to drop it into my VMs folder. So let's create a generation 2. Yep, 1 gig looks okay. Let's select the external virtual switch. All right, and let's create a small little one, say about 30 gig, and install from the ISO. Okay. So I've got some of these slides, what do you call these steps, all pre-created in slides. So if any of you are interested in those slides, I'm more than happy to upload them into the OneDrive share for you. Ah, there you go. So it's loading up now. So I have a virtual machine running within a virtual machine, and it's in the midst of being installed. That's good. So, oops, I missed it. Malaysia. Okay. So as you can see, the performance is actually not so bad. All right. However, I've noticed that if you do many nested virtual machines, you do need something a lot more capable, at least from a disk IOPS perspective. So I would highly recommend those of you who want to play a bit more, try using SSDs if you can. So and for those of you who may have this nested running, I noticed recently there may be a couple of updates that were released that may have caused the nesting to not work very well. Okay, so go online and do a search for the errors, and I can't remember now, they might already be a fix out. So go ahead and do that. So what I'm going to do now is I'm going to pass you back to Simon, just to show, just so that I can continue with his slides. Thank you, Simon.
Great, thank you. Okay, I'm presenting my desktop. That should come through in a moment for everybody. We have a question. Is this feature available in Azure? It will be once the Azure platform upgrades to 2016. So once Azure does move all of their fabric to the latest version, then yes, you will be able to do this within Azure. However, once 2012 came out in the past release, it took them about 18 months to upgrade. So the expectation is that this time hopefully it will happen within a year, but it will take a little bit of time before this is available in Azure. And one of the most interesting scenarios when you start to think about this with Azure is actually doing disaster recovery of an entire data center at once. So instead of just doing disaster recovery of a single virtual machine, where you move it to Azure and then have to reconfigure all the networks, you can in theory be able to take your cluster and all of those virtual machines running on it and all that entire configuration and move that entire data center or that entire rack to Azure. So it'll be able to offer disaster recovery as a service, not at the VM level, but at the actual entire infrastructure level. Great question. Hopefully that one will be in Azure very soon. So let's talk about one of the main implementations now of this nested virtualization. Beyond the whole dev test lab scenario, what is the big advantage? And so the whole reason why we finally decided to include it in this release was to support Windows containers. And Windows containers are a new type of virtualization. It does micro-virtualization of the different applications. So it basically allows us to separate applications from the operating system. And there's going to be two different types of containers. There's going to be a container that runs directly in Windows Server, and then there's going to be a container that runs within a virtual machine. And we'll talk a little bit more about kind of the trade-offs once we understand conceptually what exactly is a container. So in this example, we have my physical host. On that physical host, we have the operating system. And then anytime that I install an application into that operating system, I'm basically merging all of the code. So each of these 6 different applications is now directly integrated into the operating system. It's not a separate application. And what I mean by that is, there's different binary files. There's registry keys. There's libraries that the code calls. These are now embedded or kind of smushed together with the core operating system. So if I wanted to go and clone this, I would have to do a clone of that entire operating system with the applications in it. So what we're now doing with containerization is essentially separating the operating system, and in this case I have a virtual machine. Oh, sorry, let me take a step back here. What I'm actually showing in this slide here is when you're doing virtualization that you still have the same problem. So in this case, I have my physical operating system with Hyper-V. I have my guest operating system, and then the applications that are part of that guest operating system. So think of this again as a virtual machine that might be running, let's say, SQL Server. Again, in this case, we basically smushed together the code in the binaries with the core operating system. So if I want to go and clone one of these applications, I still have to go and clone that entire virtual machine. And so Hyper-V virtualization, one of the benefits here is the flexibility, that you can do things such as cloning, quick deployment. But one of the challenges here is also scalability, because every time I want to clone a single application, I have to clone that entire 6 to 10 gigabyte operating system as part of it. So what we're basically trying to do here with containerization is provide separation for the operating system and the actual application itself. So think of this kind of similar to AppV, application virtualization. Now behind the scenes, the technology is implemented extremely differently, so they caution people to say it's the same as AppV, but conceptually it is. You're basically isolating the application from the operating system. And when we isolate it, we include that actual the actual application and then also the files that it depends on. So this is going to be the registry keys, binary files, library files, things like that. Those are also separated. Now, if we go and include virtualization on this host, I can have some of these contained applications running on the host. I can have my virtual machine that's also running on the same host. And then within the virtual machine, I can also have containers again. So what we're basically doing here is saying that you can go and separate these applications, whether they're running on physical hardware or whether they're running inside virtual machines. We give you portability for that application. So anytime I go and deploy a container now, I could deploy it completely independent of what operating system it runs on. Now what this basically means is, so long as I have a Windows Server 2016 operating system, I can now take any contained application and run it on any Windows Server 2016 OS. And so a lot of people are saying, okay, but this is kind of similar to what we had before with virtualization, where you can go and take a virtual machine and run it on every host. And again, you're correct. It's kind of the same concept. but instead of having to clone that whole virtual machine each time, which might be 6 to 10 terabytes, all we have to do is clone that application each time, which might be a couple hundred megabytes. So this gives us a lot of benefits. It gives us the same flexibility that we have with virtualization, with quick deployments, easy cloning, things like that, but it allows us to do it at a much smaller level. So again, I don't have to take this 6 to 10 gigabyte operating system and clone that entire thing each time. I can just clone the application. So kind of the key scenarios here with this is gives us very rapid scalability. So if I'm building, let's say, a website, and I need to go and clone the IIS web server and spit up more instances, I can just clone the web server piece of it. I don't have to go and clone that 10 gigabyte entire operating system each time. So this means that in these dynamic cloud environments, I can spin things up much faster. I can start these containers much faster than having to start the entire operating system, because all I'm booting is booting the application. I'm not booting the operating system and then the application. Excuse me. So a lot of people say, okay, well, this is great. Why wouldn't I go and use containers for everything? Is there still a need for virtualization with Hyper-V? And there absolutely is. The downside of containers is that they share the same operating system, right? I have 4 different container applications all running on one operating system. And so even though the specific pieces for that application are separate, there's still shared information. The networking's shared, the file system stack is shared, things like that. And so what that means is one container can starve other containers running on that same operating system. There's basically no isolation within the containers. And so this means that if you're a hoster, you wouldn't want to go and have multiple individual containers running on the same operating system, because different tenants could go and interfere with each other. So what is the best practice here? You know, containers have the scalability, but they lack the isolation. Virtual machines, they have the isolation, but they lack the scalability. So kind of the best practice here is almost a best of both worlds approach. For each individual business unit, or for each individual tenant, or individual user or project, give them a single virtual machine that's isolated, and then within that VM, let them run containers that share information. So if I'm a hoster, I'm going to give the Coca-Cola company one virtual machine. Within that Hyper-V VM, they can do whatever they want with their containers to get that scalability. My second tenant, let's say Pepsi, I'm going to give them an entirely isolated Hyper-V virtual machine and let them do containerization within that. So this way, I still have that advantage of the isolation between the different tenants where they can't interfere with each other, yet within their own environment that they own and manage, we can get the advantages of scalability through containerization. So this is definitely more of a, currently it's really a developer-focused feature. There's very limited control on the interface. It's scripting primarily using PowerShell, but certainly it's going to be interesting to kind of follow this newest trend in virtualization and see where this goes. You may have heard of Docker, for example, as one of the hot technology companies in the world, and that's basically doing the same thing, containerization, but doing it on Linux. Now, another related component of how all of this fits together and how containers work is Microsoft has introduced a new version of Windows Server known as Nano Server. And Nano Server is basically an even more stripped down version of Windows. So if you kind of think about Windows Server, it comes with the full graphical user interface. Then you have Windows Server Core, which takes away some of those pieces of it. Now, Nano Server was built slightly differently. Instead of trying to remove these different components, Nano Server was built from the ground up as a highly optimized, highly efficient operating system. There's absolutely no graphical user interface. There's not even remote desktop protocol to it. There's not even a console on it. It's fully remote managed as basically a lightweight, easy-to-use server or virtual machine that can run Windows, clustering, and some basic applications. And so the whole idea behind Nano Server was to be able to support containers for rapid deployment. Each of these Nano Server operating systems is only 400 megabytes instead of 4 gigabytes. So every time I need to go and spin up a Nano Server, I can now do it in a matter of seconds instead of maybe a matter of minutes. So Nano Server is going to be the recommended deployment option moving forward for Windows Server for applications that are supported within Nano Server. A Nano Server can be run as a virtualization host running Hyper-V VMs, and of course you could run anything within those VMs itself. So again, NanoServer can be a VM, it can be a host, it can be a container, but it gives us an extremely efficient operating system. And another big advantage of this, since there are so few components running inside it, it means there are fewer components that need to be serviced or patched. And because of this, it means that you have a more secure operating system. There's fewer attack points, you need fewer reboots, which means you're also going to get higher availability, less downtime. Now, additionally, Microsoft focused a lot on using System Center to go and help manage all of these enhancements. Now, for the most part, with Windows Server 2016, System Center 2016 hasn't really made a lot of enhancements. What it's really been doing is being updated to support Windows Server 2016. But a lot of the newest management features are not going in System Center anymore. They're going in Microsoft's Cloud Management System, OMS. So what you're really going to see here throughout the slides is when we look at the additional management from System Center, it's really just being updated to support all of the latest Windows Server 2016 features. Let's talk about networking. So within networking, there's been a lot of enhancements made around performance, taking advantage of the latest hardware that's available. So Microsoft's been working closely with most of the hardware partners to do faster live migration through RDMA and better interoperability throughout the entire network stack. Now they've also agreed to support with this version the software-defined network protocol from VMware, which is known as VXLAN. And so a lot of people were surprised by this, but Microsoft and VMware, they've actually come to an agreement around network virtualization and said, let's not compete over this, let's not have siloed network infrastructures, let's do interoperability. So you're going to see Microsoft support VMware, and likewise VMware will support Microsoft's software-defined network protocols. Now, networking resiliency has been a challenge when it comes to virtual machines as well, and clusters. One of the most frustrated scenarios that people heard from the cluster team was if you had one node that was isolated, meaning that the cluster couldn't speak to this other node, even if the VMs were healthy and running, it would actually trigger a failover. So that's not good because there was really no need to do that failover at all. So what happens now is if there's a disconnection between the cluster nodes, they're going to try to reroute traffic and see whether those VMs are still healthy. If those VMs are still healthy, it's going to keep that cluster node running, keep those VMs running, so that you get better resiliency and uptime, even with temporary network failures. There's also a new concept introduced known as site-aware failover clusters. And what this means you can do is you can designate one or more cluster nodes as a site, and do the same with other sets of cluster nodes. And then within each site, you can control different policies differently. So instead of having some universal controls over the frequency that health checks get sent, you can now break that down and manage them more granularly and have site-level controls based on the frequency that you send out these updates, these pings. So it gives you a little more stability if you have a diverse distributed environment. Now, probably one of the biggest enhancements coming around networking is this new role known as the network controller. And this is basically a brains of the entire networking stack that's going to be included with Windows Server 2016. It's going to allow you to control everything from IP addresses to historical data to DNS, all in a single kind of console instead of having it spread out. Now, probably one of the most interesting enhancements around this is it is going to support virtualized network roles and include them as a different deployment option. And so what I mean by that is you can now deploy a load balancer that's fully virtualized through this network controller. You can also deploy other types of components here as well. Security components like firewalls. You can do Linux applications, network traffic management, software load balancers. So all of these are now going to come out with the next version and be included as part of it. So instead of having to deploy physical devices, I can now deploy fully virtualized devices. And one of the biggest requests that Microsoft's supporting here is a technology known as service chaining. And service chaining essentially allows you to go and connect the pathway of different networking appliances. So instead of you having to manually figure out that a new client has to first go through a firewall, then a VPN device, then a load balancer, something like that, you can actually designate that, hey, here's how the traffic has to flow. And all of this will be configured automatically by Windows Server to guarantee that those paths are being executed in the correct way. Now, we're also continuing to work and extend the data center. Hybrid cloud has been a big advantage of Microsoft, giving you the ability to run your applications on-premise or in the public cloud. So Microsoft's done a lot of work with different service providers to allow them to get faster connections directly to Azure. This is known as ExpressRoute. Microsoft's continuing to do a lot of work with its partners. We're one of the extension partners for the Hyper-V Virtual Switch for our security product. So it's actually been very different working with them as part of this release, as they've been very proactive to engage different networking vendors earlier to make sure that interoperability exists better out the box. And then as we take a look at management through System Center, really the biggest enhancements, again, are making sure that you can go and support the latest features through System Center, including deploying these network controllers and the additional associated roles that are part of that. Finally, let's take a look at storage here as one of the three key areas of virtualization. Now, following the same model of trying to virtualize everything, we want to do that same logic with our storage as well, where we can take a bunch of random disks, we can virtualize them, put them into a large pool, and then be able to go and manage the storage independently of the underlying hardware. And so what I mean by that is, imagine if I have, in this example, I have 12 disks, each of them are 1 terabyte. Well, what if I want to have a 3 terabyte file? That would be kind of tricky to manage in this case. But what Windows Server 2012 and onwards allows you to do is create a storage pool, where you basically say these 12 disks are a pool. Now I have 12 terabytes of storage. Now in reality, you're going to have a little bit of less due to rating, due to replacement disk, things like that. But in theory, I now have a pool of 8 to 10 terabytes. And within that pool, I can carve things up any way I want. I can create lots of tiny virtual disks. I can create some 3 terabyte massive virtual disks. But the whole idea around storage virtualization here is to really simplify the management. Not have to think about the underlying disks, but just think of pools or blobs of storage. So Microsoft's continued to enhance this, supporting different ways, different tiers of performance, and making it much easier in this version to go and add new storage and add new disks. Now within the cluster world, one of the biggest enhancements they've added here is around storage resiliency. Traditionally, if one of my hosts lost access to the storage, the VMs running on it would crash. That's not good. What we do now is we're proactively detecting the health of the network, and if one of the nodes cannot add its disk, rather than crashing the virtual machine, it's just going to pause that virtual machine. Once that storage connection comes back online, it's going to resume that virtual machine so that it keeps running. And this way, we're going to have much healthier virtual machines in our infrastructure. Now, another enhancement that's been added, and I think is going to be one of the more popular features, is a technology known as Storage Spaces Direct. And the best way to think about this is clusters with zero shared storage. So if you are an SMB and you can't afford enterprise storage in a SAN, and you don't have an extra server to create a file share, you can now create clusters entirely using direct attached storage. And essentially what happens here is you configure 3 or more nodes, you assign one of the disks, let's say the D drive, as the cluster disk, and it's going to make copies of that cluster disk and basically mirror them across the other nodes. So when my VM's running on node 1, it writes to node 1, but that data is replicated to node 2 and node 3. This way, if I crash and my virtual machine starts on a different node, it immediately has access to the data. So I think it's going to be a pretty big feature coming out here. It's really going to simplify cluster deployment and management, giving smaller organizations an opportunity to get high availability. Now, continuing around the storage enhancements, there's been a lot of additions around quality of service. And quality of service basically is going to allow us to better control the amount of disk I/O for a particular VM. Now, quality of service has been around since 2012, 2012 R2, but it had a lot of limitations, and those have all been addressed in this release. Probably the biggest one was that you could oversubscribe the amount of I/O. And this way, it still wouldn't have a good way to control how much memory or disk space each virtual machine gets. So what they've done now is even if storage is overprescribed, the amount of I/O is overprescribed, it now normalizes it, so it averages it out across the different nodes. So let's say there's only 100 IOPS per second available. It'd actually be like 100,000, but 100 IOPS per second available, and I've oversubscribed to 200. Well, what it will then do is divide those amounts by half, normalize it to 100%, so that the ratios are still balanced across the disk access. And the second big feature that they've added here is as people add new virtual hard disks to the VMs, global storage policies can now be applied. And this was a challenge in the past because a lot of times tenants would have their disk limited, and so what they would do to work around that is they would just add a new disk and hope the administrator didn't notice, because there was no quality of storage setting applied to any newly added disks. Nowadays, with 2016, any new disks will automatically get these global policies applied to them. There's been a lot of enhancements around shared virtual hard disks, and what a shared virtual hard disk does is it allows you to have two virtualized cluster nodes and share a virtualized disk. Now, this technology has been around since 2012 R2, but it's had a lot of enhancements so that you can dynamically resize them, you can do replication, you can do disk backup. So it's basically become kind of a first-class citizen. And Storage Replica, I think, is going to be one of the other killer features coming out in 2016. Storage Replica provides you synchronous inbox storage replication. And what this means is I can have disaster recovery with no downtime at no loss. So a lot of people say, wait a minute, there's already been this replication technology known as Hyper-V Replica. What's the difference here? So with Hyper-V Replica, that's called asynchronous replication. And what we're basically doing is taking the virtual hard disk, and every 5 minutes, we copy over the changes to my secondary site. But the problem with that is I might lose data. If I haven't made a copy for 4 minutes and my VM crashes, I've lost 4 minutes of data. So Hyper-V Replicas are great as a lightweight solution for different types of applications that can afford data loss. So maybe things like a file server. Now, what it's not good for, though, is data that needs to maintain synchronization, like a domain controller or a SQL server. So with the storage replica, you can now do replication with zero data loss. The write happens on the first site, it copies the write to the second site, and then it commits those writes at the same time. So there's guaranteed to be consistency with all of the data. The only downside of this is there is a performance hit, because anytime you want to write to the first location, you have to send a copy over the network to a site in a different location and get a response back. So it can impair the performance of your application. So Microsoft is currently saying about 200 kilometers is the maximum distance, but it is going to be based on your application, network, things like that. Microsoft's also spent time investing in Azure-based storage too, being able to copy things up to Azure much more easily. We've also added the ability to do cross-cluster Azure site recovery here. So Azure Site Recovery basically allows us to go and send a backup to Microsoft Azure, or it allows us to manage backups across sites ourselves. So this is just another enhancement where we can use the cloud to provide management, to control failover, site recovery, things like that. Because if we're moving an entire data center from one site to another, it's not as simple as just saying move everything over. There's startup dependencies, orders, you want to have your domain controller to come online first, then databases, things like that. So using Azure Site Recovery, even within your own two sites, it gives you the controls to create plans, orders, things like that. Now, for those that are cluster experts, there's a technology within clustering known as the quorum. And with the quorum, it's basically a voting algorithm that helps you figure out which node should stay active if there's a cluster crash. Well, one challenge we had with multiple site clusters is if one site crashed, well, sorry, let me try that again. If there was a partition between the sites but they were both healthy, it was tough for the sites to determine who should stay online and who should go offline. So what we can now do is take advantage of Azure. We can basically put a little file up in Azure, and one of the sites, the site that accesses that file first and opens it, they're going to win, they stay online. The site that can't access that file because it's already being used, they're going to stay offline. So it simplifies the voting. And then around management with System Center, it's kind of the same story. System Center 2016 has been enhanced, but specifically to support the latest Windows Server 2016 technologies. Now, another management tool that I'm going to show you with a quick demo is Five9's product. This is known as Five9 Manager. And what this is it's kind of a mini version of System Center. It's taken a look at a lot of the technologies and the features that are more focused on SMBs that enterprises aren't really looking for, and provides a solution that's about 10% of the price of System Center. And so what we found was there's a lot of customers out there that say, you know, I need centralized management for my virtual infrastructure. I have 4 to 10 hosts, something like that. But System Center is just too much. It's expensive. The licensing is complex because I have to buy all of these other components I don't need, and it requires dedicated hardware to set up. So Five9's produced its own lightweight version, easy to set up, easy to use. And it actually is designed to look like VMware's vCenter. So we find out that a lot of VMware customers that have moved over to Hyper-V like using this tool because it's kind of consistent look and feel, easy to use, centralized management, and so it really helps people make that transition much faster. All right, I'm going to switch over here and give a quick demo. I know that we are running over here. I apologize. We had a little bit of a late start, but hopefully you guys are finding this valuable. And we probably got about 10 minutes or so left in the presentation here. So what we're taking a look at here is Five9 Manager. And the first thing that you'll see here is simple navigation, where we can go and select things at different levels, and it's going to filter and give us a summarized view. So I can see the health of my individual clusters, my nodes, my data center, down to the individual virtual machine. Now, another thing that I like about this is the ability to easily clone settings from different nodes. Now, one of the best practices around Hyper-V virtualization is to have consistency across all of the nodes, so that whether the VM's running on node 1 or it's running on node 10, it's always going to access the disks the exact same way, so that the VM performs the same way. So what we're able to do here is change different settings, for example. So let's say I want to drop my number of simultaneous live migrations to 4. We could go apply this change. And then we could go and apply the setting to other hosts. So I can actually immediately go through this interface and say, go make all of these changes I've made and apply them to every other host in the cluster. This way, I guarantee I can get consistency and everything will go and function the same way. Now, as we go and take a look at this further and take a look at some of the other features at the node level, we'll get all the alarms that are being bubbled up. I can take a look at standard management here and see all the different virtual machines and what's running inside the VM. From here, I can do different types of filtering. I can add custom filters, things like that, so that I can view the information which is most relevant to me. And then traditional things that you would expect, like checkpoints, cloning, moving, live migration. And we even have the ability to configure Hyper-V replication, something that even System Centers aren't able to do. You can also go and edit the settings just like you would expect with any other virtual machine, changing all of the different controls, features, and advanced features too. We can manage our virtual networks, create different types of extensions for them. We also have a built-in load balancer. So what we can do here is go and configure the health of my different hosts. I can set thresholds, and let's say that my disk I/O gets to 100% on a host. I can go and do a live migration and move that virtual machine over to a different host as well. So this makes it extremely easy to distribute the load and make sure a host doesn't get overwhelmed. This would be equivalent to System Center VMM's dynamic optimization feature. We have built-in monitoring, so you could see the current health and historical health of memory, CPU, disk, and network I/O. You can see the top VMs based on who's using the most CPU or memory, and see all different types of alarms that are happening in the environment. And then we can even take a look at historical data as well. So if, for example, I want to go and see what happened over the last week, I can load the log from the last week and go and do historical troubleshooting as well. We have built-in capacity planning, so you can see based on trending the current resource utilization and the fact that, it's trending upwards, I may need to go and acquire some new hardware pretty soon. We can also generate system status reports, which is great for compliance. So it's relatively quick for me to understand how the entire cluster is being deployed and configured, and I can go and export this to different places, in Excel, PDF, Word. And then down here, we can see all of the individual settings for all of my virtual machines. So this is a great way for me to run a report, look at all the settings in a single place, and make sure that everything's configured as I expected. we have built some best practice analyzers, and these are leveraging the Windows Server analyzers that are traditionally hidden. We've now gone and bubbled them up, placed all of them into a single interface, so that you'll be very able to work through these problems and make sure that your entire configuration is deployed as optimally as possible. So for example, when I run the Hyper-V one, it's going to tell me about a bunch of misconfigurations I have. And what we recommend to our users is run this once a week, go work your way through the list, and try your best to resolve as many as you can. And each week, just make this a project until you have the most stable infrastructure possible. We also have integrated logging, so pull in all the Hyper-V logs into a single location, making it much easier to go troubleshoot. We have a concept of a library, which is a file share, where we can take virtual hard disks, ISOs, and even templates of virtual machines. So if I want to create a golden copy and redeploy it multiple times, that's easy to do. And if I have a virtual machine I want to create a template from, I can simply select it and say, make a template from this VM, even including sysprep as an option to make it unique. We also have integration with Veeam, with Starwind, and an antivirus edition. So that kind of gives you a quick summary, a quick tour of the solution here. And certainly it's an interesting option if you're an SMB and you're looking for different ways to go manage your Hyper-V infrastructure. And we currently do support Windows Server 2016 and Nano Server, but it is only available in our beta. So if you want to try out the VNext management, please feel free to send me an email, and we'd be happy to give you access to our beta program. All right, let's wrap it up and take a look at the final set of enhancements we have. Now, security has always been a big issue with Microsoft here. So there's been a lot of enhancements around security, specifically for virtualization. Now, the first big one, this has been around for a little while. It's known as JIT-GIA, just-in-time, just-enough administration. And what this allows you to do is assign access for a particular user to a particular server or service, but only give them access for a limited time. For example, from 9 in the morning until 10 in the morning. So this way they're able to log in, perform their specific task, but then after that troubleshooting period, they then get locked out again. So it gives you kind of a safety guard where you give people access, but you never forget to lock them out or lock them out again. Microsoft's also been able to virtualize the TPM. And the TPM is a trusted platform module. And what that basically is it's this very unique security component that cannot be spoofed. Now, this traditionally runs on the host, but Microsoft's now virtualized this, allowing it to run inside VMs. And so what this does is it gives us access to this next feature and set of technologies known as shielded virtual machines and guarded service. And basically the scenario here is that a virtual machine will only be allowed to run on a host if the virtual TPM matches the key to the physical TPM. And what this has really been done is provide better security for service providers. It means that tenants can guarantee that their service provider, the administrator, never gets access to their virtual machine unless, excuse me. Sorry about that. Unless they're specifically given access to the key. There's also been a lot of enhancements around security login, getting much better information about who's accessing VMs, especially when VMs change IP addresses, because that often makes it hard to go and track who's accessing what. There's been better enhancements around cloud-based security analytics. You may have heard of Microsoft OMS, or Azure Operational Insights, which are cloud-based services that allow you to load logs from your own data center that get analyzed up in Azure. And finally, there's a new PowerShell feature known as PowerShell Direct. And what this does, it allows you to run PowerShell scripts directly within the VMs from the host without ever actually requiring you to log into the VM. Now, a lot of people would say, wait a second, that sounds like a security unfeature. That sounds unsafe. If I'm an admin and I can now run scripts at my tenants' VMs without any type of control. And that's absolutely true. The whole idea around PowerShell Direct is to help make the setup and deployment easier. And then once configuration is done, the tenant will lock the admins out. They cannot go and run any more PowerShell Direct commands on that virtual machine. And finally, we want to make sure that you're aware of the enhancements coming around Azure Pack and Azure Stack. So Azure Pack, Azure Stack is basically an on-premise version of Microsoft Azure. It's taken the same Azure technologies, but lets it run on your hardware in your data center. Azure Pack's the version available on the market today. Azure Stack is coming out with 2016 as the next generation. And what you're now able to do is configure a user experience both for tenants, like with Microsoft Azure's public cloud, but also as the administrators, giving you the control of the back-end hardware. So this means that you can configure the size of the virtual machines, the storage policies, replication policies, everything like that, giving you the ability to run Azure in your own data center and guarantee that the data that you're managing from your customers stays within the country and doesn't go up to Microsoft's public cloud. So something to certainly consider if you're a service provider. So as I wrap this up here, I hope that you've seen that there's been a lot of enhancements, and the focus of virtualization is no longer just about compute. Focus of virtualization is all around the networking as well as the storage. And so you want to conceptually start thinking about those same benefits that you have on server virtualization to the storage and the network virtualization, giving you more flexibility, control, scalability, granular management, easier deployment, and higher availability. With that, I want to point out some free resources that we have here. As always, I'm a big fan of the Microsoft Virtual Academy, a great way to learn about the latest technologies. And of course, you guys have a great local expert here with Noel, who will be continuing to run this series of videos to give you more information about the upcoming version of Windows Server. Well, with that, I'd like to wrap it up, and I am willing to take questions. So please feel free to ask me questions either through audio or type them into the chat window. And for those of you that do not have questions, I certainly appreciate you coming, spending some time with us, and learning about the next version of Hyper-V with Windows Server 2016. So we have one question here. Is Five9 Manager a free trial, fully featured, limited? How does that work? So with Five9 Manager, we're going to provide you with a 30-day free trial, which gives you access to all of the features. After 30 days, you either have to acquire a license, which is about $350 per host, about 10% of the price of System Center, or if you do not acquire a license at that point, it's going to revert to the free mode. And the free mode basically limits you to manage a single host with 6 virtual machines. So this is, kind of ideal if you're just a single host. I recommend just having the free version straight away. But by using the trial version, you'll get access to all of the features for multi-host management, live migration, optimization, monitoring, things like that. And we do all of the licensing consistent with Windows Server. So we license per 2 CPUs. So if you buy, let's say, 6 Hyper-V host licenses, you would buy 6 Five9 Manager licenses as well. Are there any other questions? Yes, the licensing is per host. That's correct.
All right. Thank you, Simon. Thank you for taking us through the hour and more. All right. And apologies to everyone for the earlier false start, if you want. All right. Even somehow muting Simon and the recording also dropped out. So because of that, we had to overrun a little bit. All right. In fact, my demos, just the installation is finished. All right. So if any of you want to have a look at that, I'm happy to show. Right. But I don't want to hold Simon back. It's late where he is, and really appreciate the time you put in to put, your slides and your demos together. And thank you for allowing me to do my part to hopefully make the session, even better. All right. Thank you, Simon.
Absolutely. Thanks for having me, and I wish all of you a great day. Thank you.
Thanks, Sam. Thanks a lot.
Thank you.
Thanks, guys.
You're welcome. Welcome, everyone. Thank you. Take care.
Bye.
Bye-bye.